Now we are ready to deal with chapter 5, and chapter 5 is classification of systems. Which systems? Air conditioning systems. And remember, in chapter 5 we are learning the different types of system. You see, right from window to chill water system. We'll not deal with the selection. Selection will do in chapter number 8 after load calculation. Okay. Why? Because for selection we required the capacity, how much capacity or the tonnage for to select the machine. So this can be done only after completing load calculation. So chapter 5 and chapter 8 are interrelated. In chapter 5 we are learning the different type of system, how the system works, the cycle involved, the advantages, disadvantages, appearance, size, capacity, etc. Okay. So if you know all this, then we'll deal with the load calculation. After completing load calculation with the selector system, will complete machine selection of the selector system. So if you know the system, then only you can go for machine selection. So for example, if you miss chapter 5, it is difficult to deal with chapter 8. Okay. So that is also one reason you must attend this in sequence. You cannot miss the class. If you miss quickly, you must update, because we are dealing with the design means, as I said, it's like a chain. You cannot miss a single link. If you miss a link, you cannot complete the chain. Okay. So just I'm explaining the importance of this topic. So we'll start with this. So first, window. Just let me read this. The very small is window. Next, split also is small, limited capacity. Ductable split is for medium projects like a supermarket, limited, not big supermarket, or a office, etc. Then we have package. Package we have higher capacity compared to ductable, and it's a single unit like window. Then VRF. VRF also medium category, means similar capacity like package, but not like chiller. Just I'm giving the idea. In detail we'll discuss, don't worry. Then finally, the most important topic for high-rise building for big project is chill water system. Okay, and remember, point 1 to 5 you can update this, put in the flower bracket and write this as DX system. DX system is what? In bracket you can write direct expansion. Okay, 5 is a DX system. DX system is in bracket you write direct expansion system. And this point number 6, under point number 6 you can write chill water system. Chill water system. And in detail we'll discuss what is DX and what is chill water. Let me start first with the window. So before starting any of this, I'll play one small video clip. First of all, I'll show you the different components. Under different components, we'll deal with the system. Let me play a video, because in vapor compression cycle, just we'll learn the concept how we are getting the cooling effect. And the same cycle you'll find in all the systems. With the video, I'll show you the components and how this component will assemble and how it will connect. Okay. So this is interesting, and this video belongs to Zamil, like Voltas in India. Voltas belongs to Tata, local brand, India. Similarly, Zamil belongs to Saudi, the local Saudi brand. So this video belongs to Zamil. Zamil manufacturing site visit.
Motor. Air conditioners have two assemblies.
You see, most commonly in India we used to call window AC, but in other location, commonly this is known as room AC or single AC. Okay, and remember, window and split comes under unitary system, not central system. Unitary means one room, one machine. Okay, so
lines producing over 12.
Can you see the base online here? This is a window AC base, and on this base
100 RACs per day.
Here you'll find the partition. Okay, this side you will find inside the room, and other side will place outside the building, means outside the wall. Why we'll discuss. And this black color is called blower, type of fan. Okay, and this blower is connected to a fan motor. I'll show you.
The process.
So here you see, here is a fan motor. One shaft is connected to the blower, which is used to circulate the room air, and the other shaft will connect to an axial fan, which is used to suck the air from outside and throw on condenser to cool the condenser. And you know, vapor compression cycle, we are learning the same. Okay, in vapor compressor cycle, you know the components: compressor, condenser, expansion, and evaporator. We are dealing with the same. Additional is a fan motor. But here we are talking about the application side. In vapor compression cycle, we'll learn the concept, how we'll get the cooling effect. The same cycle used in this. Okay, next.
Begins with the assembly of the mechanical components.
What about this? Yes, you know compressor, right? And you see compressor with this rubber. This is used. This is called isolator. This is used to reduce the vibration from the compressor to the unit.
Starting with the base pan, compressor, condenser coil, evaporator fan
You
shroud,
see, this is condenser fan. So one motor, two shafts. One is to circulate the water inside and circulate the air inside, and the other is used to circulate the water from air from outside to outside only to cool the condenser. How exactly? I'll show you.
evaporator coil,
You see, these are heat exchangers. And 1 minute, I'll show you this image.
One essential component in air conditioners must be the heat exchanger in its dual application.
Here you see, this is heat exchanger. Can be used for condenser or for evaporator. The size is different, but the component is same. Both are heat exchanger. And here you can find out the copper tubes. And what about this? These are all fins. So the default or the common configuration for this heat exchanger for condenser or for evaporator is copper tube aluminum fins. But in market you'll find aluminum tube aluminum fins, or copper tube blue fins, copper tube red fin, or with a different coating. But the default configuration is copper tube aluminum fins. So you know why this tube? Tube is a heat exchanger to reject the heat to means at condenser and to extract the heat at evaporator. Then why these fins are required? It is used to increase the rate of heat transfer. You see, when the refrigerant is flowing, if it is a condenser, the hot refrigerant is flowing now. And when the hot refrigerant is flowing, what will happen? The heat will quickly transfer to the fins, and this can be easily transferred with the air to outside. Okay, so with this fins we are increasing the surface area. And you know, as a mechanical, you know, fins are used to increase the surface area to increase the rate of heat transfer. So they're same concept. Okay, so next directly I'll jump to the same 955. And can you see these tubes? These are capillary tube, expansion device. This process is called brazing, you know.
After the brazing comes the air pressure leak test.
So with this image you'll get 4 components. I will start from the left. So this is what? Condenser. This is outside. And here it's not visible, but okay. So next is what? Inside. It's not visible, but you can assume here compressor na inside. And this is a fan motor. One shaft is connected to axial fan, which is covered with this other inside blower. And here is a expansion device capillary tube, and this is evaporator. Okay, so the 4 components, and you know the cycle. So this, if I draw the line, this part will be outside the building, and this will be inside the building, and this part will suck the air from the room, and this fan will suck the air from outside and throw on this condenser to cool the condenser to get the refrigerant in liquid state. Okay, and after that liquid state, you know, through this expansion device, we'll get the cool refrigerant with a low temperature pressure and flow in evaporator, and in evaporator you'll get the cool refrigerant, and when the air suck from the room, it will pass through this evaporator, loses the heat and what? Moisture. So you'll get the cool, at the other side you'll get the cool and dry air, means cooling and dehumidification, the same concept. Okay, next, but one more important point, let me play this. Dehydration means extracting the air from the heat exchangers, and refrigerant charging. And remember, refrigerant charging always in compressor in gas state by the manufacturer or on site as per by the service team.
And refrigerant charging.
Means in window means by the manufacturer.
Following electrical component assembly, complete unit testing is performed in addition to a functional test and one final refrigerant leak test.
So here you'll find one interesting and important point. Yes, online and class, can you see this sensor? See, this is a temperature sensor, and point 1 to point 2, this is written from the room, and point 2 to point 3, this is supply from the room. And you know, the front panel, a window, left side you'll find some grills, right side you'll find some openings. So right side is supply and left side is suction. So this is for return air and this is for supply air. Okay, means the same air circulate within the room, and when the air suck, first it will monitor the temperature, it will sense the temperature, then it will passes through the coils and fin, loses the heat and temperature, and you know, the blower will suck the air from the center and supply to the periphery. Okay, and the blower will suck the air from the center and supply to the side, and you'll get the cool and dry air from this outlet. And you can see this return is area is more and supply is small. Okay, and you see same air volume is circulating now. So if the area decreases, what will happen to volume? And I think you know, Q equal to AV, continuous equation. So here area is less, means velocity is more. Here area is more, so velocity is less. Okay, so return with the low velocity because area is more, and supply with the higher velocity to avoid the short circuit of air. Because both are very close now. If I maintain the same velocity, it can, the cooler directly may suck in the return. Okay, anyhow, this is not completely follow the standard of as per air conditioning, but commonly this is used in market, so we need to learn. So supply with the higher velocity, return with the low to avoid the short circuit. Apart from this point is important. So whenever air suck continuously, the return air temperature sensor will monitor the return air temperature. Okay, then why it is required? For example, I think you know, in window also you'll get the remote. Suppose with the remote, if I set say 23 degrees centigrade, my required temperature in the space, in the room, I switch on the AC and I set 23 degrees centigrade, but present room temperature say 30 degrees centigrade. I think you know, in the display you'll find room temperature and the required temperature. Required temperature, for example, if I set here 30 and room temperature is showing 23 is the required temperature, room temperature is showing 30. Okay, in the remote also you can find out that how much you set and how much is present. So what happened if I set 23, present 33, after some time what happened? From 30 to 28 and 26. So after some time this temperature will attain, and after attaining the temperature, the machine should control the cooling. If not, what will happen? If the load is less in the room, then continuously it will extract the heat and the temperature will be less than 23. It can be 20 or 15. If the very load is less, if it is starting somewhere, then it can reach to 15 or 10 also. So that will create discomfort. So means some controlling is required. So remember, controlling is done always based on the return air temperature. Okay, so whenever the return temperature same as what you set, say 23 I set, and in the return also sometime cooling is attained, in the return also same 23, means the machine will switch off the compressor, because this sensor will continuously monitor what you said. If you get the same, this sensor will give the signal to thermostat, and thermostat will control or switch off the compressor. But the fan will run continuously to maintain the air movement. After some time, if the load increases, if the temperature increases, because it is monitoring continuously, then again suppose after some time the temperature is now say 24 or 25, quickly it will, the sensor, with the sensor the compressor will switch on. Like this the machine controls. And remember, this controlling is not only for window, this controlling for all the air conditioning system. Okay, in split, in ductable split package, even in chill water AHUs. What is AHUs we'll discuss. So remember, the return temperature is responsible to control the room temperature. But in chill water system, we'll talk about the return water to control the chiller. But again, the chiller is connected to the air side unit called AHU. But in AHU the concept is same, or in FCU the concept is same. But if you don't know AHU and FCU, don't worry. we have a topic in this chapter 3 only. In detail we'll discuss, because this AH and FC also one very important topic to discuss. Okay, so I think got the idea how this window air conditioning system works. So quickly we'll complete this today with the theory. Okay, tomorrow I'll play the same video. So first I'll show you the part for split AC, then we'll complete the split AC. So let me complete the window here first. So window AC, also known as single or room AC, capacity common in most commonly 0.75 to 3 TR is available. But remember, this capacity may vary as per manufacturer and even as per location. So in some location you'll find up to 7 TR this window. But most commonly for interview point of view, 0.7 to 3 TR. Even 3 TR also directly not available in India. If you want, you need to place a special order. To 0.75, 1 TR, 1.5, 2 TR is commonly available. Okay. Next, application can be used for small room, shops, small offices, etc. Means it's a unitary, so room AC, one room, one machine. Okay. Or if the room is big, we require 2 machines in 1 room. Okay. But in case of central air conditioning system, 1 unit can cover multiple spaces. That case is different, we'll discuss later. But this system is for 1 space or multiple unit for 1 space. So it's a unitary system. Okay. Next, advantages, low initial cost. You can purchase this with the starting say 25,000 for 1 ton starting range. So initial cost is limited. Compact in size, very small, limited space is required. Easy to install, because it's like a plug and play. No need to fill the refrigerant, no need to do the commissioning on site. Simply like plug and play. We required 1 frame can prepare by carpenter and 1 rated electrical supply. Just that's it. We can easily install this. Next, low maintenance. Once in a season, if you do the servicing cleaning, it can run minimum 3 to 5 years or more than that as per the usage, as per the location also. But the disadvantage here, you see, ventilation is not as per ASHRAE or as per standard. Why? I'll show you one more image to get this idea. Here, you see the same air suck and supply. Is there any supply of outside air? This side is outside and this is inside, right? So you see inside air suck and supply to inside only. And this arrow is showing some air is entering inside. But don't think that this air is entering inside. You'll find the complete partition. Na? It is a section view. But in the video, you know, complete section. So this direction is not mean that air is entering inside. This direction of air means this air is used to cool the compressor to maintain the efficiency. So outside air is from outside to outside only, which is used to cool the compressor, and the major task is to cool the condenser. Okay, and inside air is inside only. But in some models, you'll find some option here, some opening with the knob from inside. We can open or close to introduce some amount of fresh air. But again, that amount of air which is added is not as per standard. Just a limited amount. It's not calculated. Okay, so in few models you'll find some fresh air option, but still the fresh air is not as per standard. Why? Because this window AC available with the limited capacity. If you provide the fresh air as per standard, what will happen? The fresh air in summer is hot and humid, will directly affect to the load on the coil. The cooling will reduce. Okay, so it is available with the limited capacity, so it's difficult to deal with the required or standard fresh air. Okay, so the first major disadvantage is not having ventilation as per standard. We are following ASHRAE standards, so it is written ASHRAE. If you're dealing with any other standard, so it's difficult. Next, noisy type of machine. Why? Because the compressor is close to the conditioner space, na? And you know this, it will create a lot of noise. Next, comparatively high energy use. Compared with what? Chillers. You see, you cannot compare this window with the chiller in terms of capacity. Chiller capacity start with 15 TR up to 3,500 1 unit with air cooled, and for water cooled up to 6,000 TR 1 unit. But here, window is available limited to 3 or max 5, max 7 TR. Okay, so I'm not comparing this window in with respect to the capacity. Just I'm comparing the energy use. So how much energy, electrical energy consumed by window for 1 ton. If I compare with the chill water system, the chill water system power consumption is less. But how? After learning the chill water system only you can understand. So remember this point you'll find for all the DX system compared with the chill water system. Means all the DX system running cost is higher compared to chill water system. So after learning chill water system only we can compare. So at this level remember this point. See, look ugly in building elevation. And in Dubai or in UK, the municipal will not allow you to install this unit or at the elevation side. If it is visible means they will not allow, or they will put challan. So anyhow, even in India also, if I use this will affect to the building elevation, like boxes at the elevation side. Okay. Next, no uniform distribution of air. This is also one major disadvantage. And we already learned air conditioning means motion and distribution is fourth parameter na, in air conditioning. So this machine cannot provide the uniform distribution of air because we are installing at one side or in between the room, not on the ceiling na, so it will supply the air in one direction. So you cannot expect the uniform distribution of air. For uniform distribution, either we can use a ceiling fan or a separate wall mounted fan for distribution of air. So this is also one major drawback. Next, exposed wall is required. Can we install window in between the two rooms? For example, this is room 1, this is room 2. Can we install, suppose this room 1 is non-AC. So can we install in between these two rooms, non-AC and AC? Why? We cannot install. Why? Because what will happen, this side the rejection of hot air from means it will continuously reject the heat from the condenser. So if it is a non-AC room also, after some time the room temperature increases because continuously we are throwing the heat out, and after some time the suction air temperature and the throw air temperature will be same. If the temperature means this refrigerant temperature and the air temperature is same, if there is no difference, means there is no rejection of heat. Initially it can work for 15 minutes or half an hour, but after this the room temperature increases, and when the room temperature same as the refrigerant temperature, there is no rejection. No rejection of heat means no cooling. Okay. And if this is outside means what? Continuously moving air na. So whenever hot air throw means it will suck, it will replace with the fresh air, with the new air. It's like a source. Continuously we can reject the heat to outside because it's a moving air. Okay, so exposed wall is required to install this. Okay. So these are the disadvantages. Next, one more point, drain. Here you see, we already learned when the air passes through this evaporative coil, we'll get the cool and dry air. Cool and dry air means the condensation on the coil. Na? So the condensation on the coil means the water droplets. So this water droplet is collected at the bottom and reject with the drain point. So at the time installation, slightly inclination towards the drain point so that the water can reject easily. And I think, from the windows you'll get the water. This water from the room air, not from the machine, not from the unit. Okay, so continuously condensation. So as per standard, 1 ton can extract 1.2 liters per hour. As per standard, this dehumidification capacity. This is standard, but as per the requirement also we can design. Okay, so remember this point, dehumidification, water droplets on the coil. Okay, and why this water droplets? Because on the coil you can expect temperature less than equal to dew point temperature, right? Clear? So these are all about the window AC. So done for today's session. Tomorrow I'll continue with the split. Okay.